Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.1, integration by part 2. Number 1, integration requiring t-substitution. Here comes the first example. Integral e square root x dx. So to do this integration, the trick is gonna let t equal root x dt is 1/2 root x dx. So you can see that dt is 1/2 t dx. So we see that dx is 2t dt. Now when we do the substitution, we have integral et times 2t dt. Well, to do this, we do integration by part. We let u be 2t and dv be et dt. du is 2 dt, v is et. uv 2t et minus the integral of v du 2 et dt 2t e to the t minus 2 e to the t plus c. Now we do the substitution. 2t is square root x, so 2 root x e to the root x minus 2e to the root x plus c. Pretty cool. Here come another one. B. Integral cosine of ln(x) dx. Oh, this looks pretty difficult. The trick is we can do the t-substitution. Let's move it up here. Let t equal ln(x). So I mean e to the t is x. And then from here we see that et dt is dx. Oh, do the substitution and we have integral cosine t times et dt. To do this integration, we're gonna use integration by part. We got to pick u and dv correctly. So u is e to the t and dv is cosine t dt. du is et dt. v is sine t. Using integration by part, we have uv et sine t minus the integral of v du et sine t dt. Now we need to do another integration by part. And we're gonna let u to be et, dv to be sine t dt. du is et dt. v is negative cosine t. So we have et psi t minus uv, so negative cosine t et minus the integral of v du, so minus et cosine t dt. Yeah. And this gives us et psi t plus et cosine t minus the integral of et cosine t dt. So now notice that we can add the integral of et cosine t dt on both sides. This cancels out. And on one side of the equation, we have a 2 times integral of et cosine t dt. On the other side, we have et psi t plus et cosine t. So the integral of et cosine t dt equal to, well, divide both sides by half of et psi t plus half of et cosine t, and then we gonna have a constant c here. So next step is do the sub. T is L1x, right? And then et is x. So we have a 1/2 x sine L1x plus 1/2 x cosine L1x plus c. Oh, pretty cool example. Let's take a look at a few shortcuts. There are some integration that we can use the shortcut, and the integration having this form, we can use the integral xn ex dx, integral x to the n cosine x dx, integral x to the n sine x dx. This integration comes up very often in a differential equation. So what is the shortcut here? Let's take a look at an example. Integral x squared cosine x dx. We did it in the previous lesson. U is x squared, so we write x squared on one side, and then dv is cosine x dx. We're just gonna write cosine x there. So on one side, we're gonna differentiate. On the other side, we're gonna integrate. Derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. Okay. Can't do anymore. Now integrate cosine x. Get a sine x. Negative cosine x. Negative sine x. Notice that when we do the integration by part, it is always u v minus integral v du. So we're gonna stick the u times v. x square times sine x, and then 2x times negative cosine x, 2 times negative sine x. The sign will alternate between plus and minus. It will be a plus and then minus plus. Notice that this is the initial integral. And when we get to this part where this is the terminal integral. Okay. So using the shortcut, the integral of x squared cosine x dx, this x squared sine x minus minus turn to a plus 2x cosine x plus minus is a minus 2 sine x, and then the integration of 0 is c. Let's take a look at another example. Integral x to the 3 ex dx. We're going to differentiate on one side and integrate on the other side. X to the 3, 3x squared, 6x, 6, 0. Integrate ex, get ex, 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 ex. Okay. First side plus, minus, plus, minus. This integral become x to the 3 ex minus 3x squared ex plus 6x e to the x minus 6 e to the x, and then the last integral is integration of 0, so that would be plus c. Super slick. Thank you for watching. I hope you find the content useful. Please like, subscribe to help the channel growth. I'll see you in the next video.